right, so this unit is called our synthesis of functions unit. And so what it does is we are putting together everything that we've learned so far. We have three more types of functions we have to learn how to graph. But we have to start comparing some of our various graphs. And you have to be able to compare them using a table, using the graph, or using the equation of it. So one of the other kinds of functions we need to talk about is an exponential function. So an exponential function is a function in the form f of x equals a times b to the x power. By looking at the equation, you're going to know it's an exponential function because the variable is your exponent. So because we had b to the x power, that's how we know it was an exponential function. So our parent function, which to review that term, which is the most basic form of a function, would be f of x equals 2 to the x power. That is our parent function for our exponentials. So the graphs of these functions are not straight lines. In a straight line, your rate of change is constant. We've talked about that before. Remember, our rate of change is slope. If I have, like, for example, the graph of a line, I'm always going up and over, up and over, up and over the same amount. Our rate of change is always the same. It's constant. In exponential functions, however, the rate of change either increases or it decreases across the graphs. So your rate of change is never going to be the same. You could look at two sets of points, look at your rate of change, get it, make your set of points wider, or look at more points, and it's going to change. It's never going to be the same rate of change. So let's look at some of our basics for our exponentials. So when evaluating an exponential function, you need to plug the given value and simplify. So here's our function. They want us to find it for when x equals 3. So we're just going to plug a 3 in for our x. So it's going to be f of 3 equals 4 to the third plus 2. So then we'll just use our calculator. Do you guys remember how to get an exponent in your calculator? It's that little caret button. Looks like an arrow pointing up. It's underneath your clear. So we got to do 4 to the third plus 2. We get 66. Right there. So number 2, what are we plugging in for x? We're going to plug in a 2. So f of 2 equals negative 2 to the 2 minus 3 minus 4. So let's clean up our exponent a little bit first. What is 2 minus 3? Negative 2. So we get negative 2 to the negative 1 minus 4. So let's have you plug that in your calculator just like that. Negative 2 to the negative 1 power minus 4. Hopefully we got negative 4.5. So hopefully that stuff's like second nature to you guys, because we've been doing that pretty much all year long. So here we have a picture of a graph over to the right, so they want us to get our answers off of the graph. So we're looking for the value of x when h of x equals a 1. So remember, h of x, if we were to put it in the calculator, it's the same as our y. So we're really looking for when your y value is a 1. which would fall along this horizontal line right here. Remember, if you have y equals a number, it's always a horizontal line. So how many times does our graph cross our line that we just drew? Once. And what is the x value at that point in time? What is it? 0. This is where x is 0. And you went up 1. Second one, find the value of h of x when x is 1. So again, think to yourself, they're telling you to find the value of y when your x is a 1. So let's go to where x is 1. Where's our graph? 2. So this next one says 3 times the h of 2, which remember, we normally have an x in here. So this is our other way of saying when x is a 2. So let's go to where x is 2 on our graph. We'll go up. Where is our graph at? 4. So it's going to be 3 times the 4 minus h of 0. Again, that's when x is a 0. So when x is 0, where is our graph? At 1. So 3 times 4 gives us minus 1, 11. So our answer is 11. All right, so again, just practicing some questions here. I want you to go into your calculator, type into your y equals. We're going to type in a 3 to the x power. So we're looking for the graph of this equation contains which point. So let's look at our table. Let's see if the 0.19 is in our table. Do we have the 0.19? No, we got 1,3. So that's not it. How about negative 2 1/9? Well, negative 2, we got a what there? 0.1 repeating. So let's just see for a second. I'm going to exit my table. What's 1 divided by 9? Is it the same decimal? Yeah, so we have negative 2 1/9. So that one ends up being choice 2. Number 2, which of the following points is on the graph of the exponential function whose equation is y equals 5 to the x? Let's have you guys try that one on your own. So plug into your calculator 5 to the x power under your y equals. See which one of those points is in there. All right, who's got the answer? Which point is there? 0, 1. Choice 2. All right. So, graphing our exponential functions. Let's take a look at the back of that first page. You always need to include a table of values. I've been telling you that all year, table of values. Unless you're graphing a line, you could tell me m equals b equals. For your exponential functions, you need to have at least 5 points. You can have more than 5 points, but you need to have at least 5. In your table, this is the only one you need to include some decimal values. I say you only need to have 2 decimals. So since we need 5 points total, if 2 of them are decimals, the other 3 should be what? Whole numbers. Again, sometimes your domain is given to you. It would look like this if it were. Negative 2 is less than or equal to x, which is less than or equal to 4. Again, that's telling you what x values to use in your table. They're telling you to go negative 2 up to 4. So you would only know what part of the table to look at. So then you plot your points and connect them with a smooth curve. Our exponentials are not lines, they're curves. And then our exponential functions have a special horizontal line that they can never cross, which we refer to as the asymptote. So we'll take a look at our asymptote in a minute. Whenever you're graphing your exponentials, you have to include your asymptote line. That's always got to be there. So let's take a look at our first graph. So we're graphing f of x equals 2 to the x power for the domain, negative 2 less than or equal to x less than or equal to 4. So that means in our table, we're going from negative 2 up to positive 4. So I can already fill in my x side of my table there. So let's have you go in your calculators. Under your y equals, type in your 2 to the x power and fill in the other side of our table over here. So now that we have our graph, we can go ahead and answer our questions. What would be our y-intercept here? Where do we hit our y-axis? At 1. So our y-intercept is 1. Is this graph increasing or decreasing? This graph is increasing. Remember, if we start at the left and we follow our graph, this one's going up. So this graph is an increasing graph. They want you to state the domain interval over which the graph is increasing or decreasing. So is this one increasing the whole time? Yeah. So our domain would be the same as the domain they gave us. So you just have to copy that. So negative 2 is less than or equal to x is less than or equal to 4. If they didn't give you a domain and the graph was increasing, what are those 3 letters we use when it's increasing? X, E, R, that X, funky E, R. That's how we know it's increasing the whole time. Then they want us next to state the range. Now, since the domain was given to us like this, your range is going to look very similar. We just got to use a y in the middle. So you can use your table to help you. What is our lowest y value? 0.25. So that's going to go over on the left. What's our highest y value? 16. So that goes over on the right. So you just got to copy the same way they gave it to you. Over what interval is this function positive? Again, is it positive the whole time? Yeah. So we use our domain again. Negative 2 is less than or equal to x, which is less than or equal to 4. If we had arrows, we would use our domain. X is an element of the reals, x, E, R. Next, find the average rate of change for the interval negative 1 to positive 1. So again, remember, those are your x values of your 2 points. We use our table to help us finish it. So at negative 1, we have 0.5. At positive 1, we have 2. So we have the points negative 1, 0.5, and then 1, 2. And then what formula do we use? Nope. Average rate of change is our slope formula. y2 minus y1 over x2 minus x1. So what is 2 minus 0.5? 1.5. And then what happens in our bottom when we have that minus a minus? Turns it to adding. So we get 1.5 over 2, which let's divide that out because we can't have a decimal in our numerator. 1.5, 0.75. Now, because this graph was an increasing graph, that's why our average rate of change was positive as opposed to negative. If we had a decreasing exponential graph, our average rate of change would have been a negative. So now they ask us, what happens to the average rate of change for the interval negative 2 to positive 2 when you compare it to the interval negative 1 to positive 1? So we already know negative 1 to positive 1 gives us an average rate of change of this. we got to look at our other interval, so we need to calculate that first. So when x is negative 2 and when x is positive 2. So at negative 2, we get what is our other part of the point? 0.25. At positive 2, we get 4. So now we have our 2 points. We can do our slope y2 minus y1 over x2 minus x1. So 4 minus 0.25 over 2 minus negative 2. So 4 minus 0.25, what do we get? 3.75, very good. And then over what? 4. So divide those, what do we get? 0.9375. So what happened? I went from 0.75 to 0.9375. Greater, what's another word that we like to use, begins with an I? It increased. The average rate of change increased. Which is what I was talking about on the front with your exponential functions. Your average rate of change is never going to be the same no matter where you figure it out from. Because this was an increasing graph, your average rate of change is going to increase as you make that interval wider that you're looking at. If it were a decreasing graph as you make your interval wider, what do you think would happen? It would decrease. Your average rate of change would decrease each time. Questions on this so far? All right, let's take a look at our last page of our day 1 notes. So I already graphed this one for you, so I made our lives a little bit easier here. This one has arrows because they did not give us our domain. So what would be our domain of this graph? XER. X is an element of the reals. So let's take a look. Is this graph increasing or decreasing? This one's decreasing. As you start from the left, you follow your graph. Your graph is going down the whole time. So this graph is a decreasing graph. Perfect. The x is negative. And because our x is in the exponent spot, that's what switched it. So if you have a positive x in these graphs, they're going to be increasing. Negative x, they're going to be decreasing. All right, state the domain over which it is increasing or decreasing. Again, we've got arrows. Is it decreasing the whole time? Yes. Yeah. So this is our XER. Next, they want us to state our end behaviors. Left side, I feel like, is pretty easy. Left side is going in which way? Up. Yeah, the right side's a little trickier because it's not straight going down, but those values are very slowly going to be going down. You could also always look at your table. If your right side, if your bottom of your table, those values are going down, that would tell you also that your right side is going down. All right, next we're stating our domain and our range, which we already talked about our domain. X is an element of the reals. You can use every single x value for your domain here. No, not the same with y. You see how the y kind of seems to level off here? What happens is right here at this -2, this is a special line that I talked about a little bit. This is your asymptote line. For this graph, it's the line y equals -2. Our first graph didn't have it because we had a set domain, so there was no asymptote. When your domain is x is an element of the reals, you are going to have an asymptote every single time. So what happens is this graph is it looks like it's going to touch -2, but it's never actually going to reach that -2 value. So our range would be y is greater than -2 because our graph is entirely above your asymptote line. If we had, for example, a graph that looked like this, let's say that my asymptote is at the line y equals 3. Your range for this one would be that y is less than 3 because your graph is below your asymptote line. What? Well, yeah. What is the equation of the asymptote? That's the equation y equals -2. Draw it in with a dashed line, which I already did. Some other people did it, and I can see. Now, finding your asymptote line, it's actually pretty easy. It's whatever this number is at the end. So our asymptote line there was y equals -2. Let's say I gave you the equation y equals 3 to the x plus 4. Where would our asymptote be? Y equals 4. What if I gave you y equals -2 to the -2 minus 1? Where would our asymptote be? Y equals -1. You got to make sure you write that y equals 1. The one, though, that people frequently miss is what if I just have 2 to the x power? Where would our asymptote be? 0, because there's no number here, so your asymptote would be at the line y equals 0. So it's whatever that last number is, that's where your asymptote's going to be. So it's pretty easy to figure out. All right, average rate of change from -4 to 0. So again, those are our x values. Now this one, it's kind of tough to read it off of the graph. So since they gave us the equation, let's have you type that equation into your y equals, and then we can look at our table. So we're typing in 2 to the -x minus 2. 2 to the -x minus 2. You just push the negative sign before you push your x. What'd you say, Matt? I got -414.
I got -414.
All right, somebody agrees with me. Okay, good. Another person agrees with me. And then we got 0, -1. All right, so now we'll do our average rate of change. So y2 minus y1 over x2 minus x1. So -1 minus 14 all over 0 minus a -4. So 1 minus 14, or -1 minus 14, I should say, gives me a -15 over a 4. -3.75. So as I told you, since this graph was decreasing, our average rate of change is negative. Or you could write it as -3 3/4, yes.